So let's come back to looking at making sense of expressions and making sense of expressions in a visual way. If you remember, we started this chapter with a set of patterns with dots inside flowers, and we had orange petals and purple circles and green circles, and we could see how the different structures, the different designs in each of the scenarios was related to the formula. Now here we actually have a slightly different situation. We have a growing pattern that we can make sense of, but then we also need to see, well, how does this grow? What is changing? What is not? What are the parameters? And what are the variables? Right? So we're going to try and to figure out a way to represent these shapes, these dots, the number of dots, in such a way that we can then extrapolate, go to 6, go to n, right, if we need to. So for example, here I see a pattern where I have a single dot in the middle, and then three of the little dots, of the single dots. Those 3 single dots become 3 arms of 2 dots, and then 3 arms of 3 dots, and then 3 arms of 4 dots, and then 3 arms of 5 dots. You see that those dots are growing, but the lengths of the arms are growing. But what we still have is a structure that is the one dot in the middle, plus 3 arms of 1 dot. For the second one, it would be 1 plus 3 arms of 2 dots, 1 plus 3 arms of 3 dots, 1 plus 3 arms of 4 dots, and 1 plus 3 arms of 5 dots. Now, if we were looking for parameters, something that is going to be constant throughout this whole scenario, right? Do you notice that the structure of these pictures is actually constant? The one in the middle is constant. It doesn't suddenly become 2. It doesn't suddenly become 5. It doesn't suddenly disappear. The 3 arms is also constant. There are always 3 arms. We're not increasing the number of arms from one figure to the next. But what is changing here, or the variable, are this length of the arms. So that's very interesting to see. And if we put it in a table, that may become even more visible. So 1 plus 3 times 1, 1 plus 3 times 2, 1 plus 3 times 3, 1 plus 3 times 4, 1 plus 3 times 5, 1 plus 3 times 6. Now notice I'm not just writing out the numbers. I could write out the numbers. So 4 and 7 and 10 and 13 and 16 and 19. I could. And I could say, well, what is the pattern for these numbers? But that pattern is hiding. When we look at the structure of how we figure those out, the pattern becomes this pattern that we were looking at before. The parameters and the variable becomes clear. So when we need to be looking at the nth term, we'll still know that the middle dot is going to be on its own. There's going to be one of them. And there will be 3 arms, and each one of them will be n long. So we can write it as 1 plus 3n. So question 2 asks you to make sense of the function, the equation, right, at the very end, or the expression at the very end, with the pictures given in the pattern. So I've talked about it verbally, but what I would like you to do is take some time and write down the kinds of patterns that you see, and how the relationship, what kind of relationship exists between the pictures, the growing pattern of pictures, and the actual expression that we have in number 1. Now, how many small circles will the 38th figure in the sequence be made of? Well, at the 38th, we'll have n equals 38, or it'll have 38 dots in each arm, right? So we know the pattern. So what's going to happen is we have a central 1 dot and 3 arms of 38. Okay. So what we're going to have here is we can figure that out. So 3 groups of 33 is 99, plus 1 is 100, plus 15. So 115 will be the number of dots in the 38th figure. Will there be a figure in the sequence that is made of 100 small circles? If so, which one? If not, why not? So try to write it down in different ways. Okay, so will there be a 100th? Will 1 plus 3n ever be 100th? So 1 more than 3n ever be 100. So would 3n ever be 99? Could 3n ever be 99? If it is, how many dots will there be in each arm? Well, there'd be 33 dots in each arm. So that's quite possible that we'd have 1 dot here, and then 33, and 33, and then 33 here. Is it possible that a figure would have a sequence of 125 small circles? I wonder. Is it possible to have 125? So if 1 more than 3n is 125, so 3n would have to be 124. Is there any way that we can make a figure with arms with 124 dots in the arms? Well, I know we can make 120, right? Because that would be 40 each, 40 long. Well, then we can make 123 too, because that would be 41 each. But in order to go from 123 dots to 124 dots, we wouldn't be able to do that, because then we would add 1 dot to one of the arms, but not the other 2. So it would not be part of that pattern. Right? So notice again, we're really making sense of what the problem is. We're making sense of it, we're trying to draw it, we're trying to visualize it. And then if there's algebra to be used, we're using it as a tool on top of our understanding, not instead of our understanding.